It's amazing what we can do in Photoshop with pictures. What is truly amazing is how our brain interprets the sensory information and creates an image of the world that we see. Studying illusions has provided great insight into how the mind works. We are built to survive, and we have to compute our sensory input as quickly and as efficiently as possible to provide us a true image of the world before us. Therefore, we can acquire different strategies to overcome situations, understanding both what us and our opponent would do. And like everything in life, timing is everything. Because decisions have to be made so rapidly, we come with preset motor and psychological programming. Determining friend from foe is paramount for survival. This next demonstration will show how the psychological mechanism of understanding human faces has been hardwired into our brain.
One side of the mask is hollow, but it doesn't necessarily look that way.
Even when we know that it's an illusion, we see it as a convex face. Even when we know it's hollow, our visual system sees it. We interpret it as being convex. Essentially, our knowledge of faces is overriding what our visual system can see. So our depth perception can see that it's hollow, but our visual system is overriding that and saying, no, I'm not in those words. It's unconscious, of course, but that's a face, so it must be sticking out.
And it's this gap between reality and what we perceive that holds the key to how our senses work.
All sensory systems receive input from other sensory systems. When we're born, we have these communication pathways, albeit primitive, not unlike a dirt road, from sensory system to sensory system. The process of neuroplasticity is how we make and reinforce our existing pathways. If I do a specific activity over time repetitively, I get better at that activity.
I have no visual memories at all.
This man lost the use of his eyes at birth. So how can he see the world in front of him?
A retinal tumor.
Like a bat, his brain is able to make images out of sound.
These parts of the principal visual cortex are now taken over by auditory information.
We employ a functional neurological exam, such as assessing primitive reflexes like the asymmetrical tonic neck reflex. Next, we look at balance and head righting reflexes. This is an appropriate response when the child bends to the left. When he bends to the right, it's inappropriate. His head doesn't level off. Now we ask the child to find his nose with the tip of his finger with his eyes closed. We're checking his mental map. He's unable to find it with his right hand. If we don't supply the appropriate sensory input to the brain, we'll make decisions based on aberrant data, selecting strategies that might be less than successful. This child is experiencing muscle weakness due to a food sensitivity. This flawed data causes a decrease in function. We then utilize brain-based treatments to restore neurological control. The result is improved function in a system that was previously functioning less than optimally. What's important to know is that we're not just making a muscle stronger, but we're restoring the integrity of the neuroendocrine immune axis. Dysregulation of this axis leads to a myriad of diseases and issues that are plaguing us today.
You're only human, you're